Building a $2 billion nuclear ghost doesn't start with cutting steel. It starts in the world's most secure engineering labs. Engineers spend years creating 3D digital models to ensure the hull can withstand the crushing pressure of the deep ocean.
Ordinary steel is useless here. To survive the abyss, engineers use specialized HY100 high-yield steel. It's incredibly strong yet flexible enough to handle the immense external pressure. In a massive facility, computer-guided plasma cutters slice through these thick plates with laser precision. Each slab is so heavy that giant overhead cranes are required to move them. These steel plates are the primary armor, the only thing standing between the crew and a watery grave. The flat steel plates are fed into massive rollers that bend them into perfect cylinders. But humans don't weld these giant joints. High-tech robotic arms do. They weld continuously for weeks to ensure every seam is flawless. In the deep ocean, the smallest weak spot means certain death. Every single weld is X-rayed and ultrasonic tested for microscopic cracks. When these cylinders are joined together, they form the pressure hull, the unbreakable spine of the submarine.
Now, it's time to install the heart of the beast, a compact nuclear reactor. Unlike traditional engines, it doesn't need oil or diesel. The uranium rods inside can provide limitless energy for over 25 years without ever refueling. The reactor is placed in the center of the ship, surrounded by thick layers of lead shielding to protect the crew from radiation. Once this nuclear heart is online, the submarine gains the power to stay submerged for years, making it a true predator of the deep.
Nuclear energy generates high-pressure steam, spinning massive turbines. But the secret to a submarine's lethality isn't the reactor. It's this. These aren't ordinary blades. Any sound underwater is a death sentence. Engineers spend months hand-polishing these bronze blades to perfection, eliminating even the smallest bubble. This is silent propulsion, allowing a $2 billion machine to glide through the ocean like a ghost. But with all that power, how does the crew breathe?
How does a crew breathe underwater for months? The answer is electrolysis. Onboard machines split seawater into hydrogen and oxygen, creating fresh air for the crew to breathe. Additionally, advanced filtration systems strip the salt from seawater to produce pure drinkable water. This means as long as there is power, the crew has air and water. It's an incredible closed-loop system that defies nature, allowing life to thrive inside a steel tube for months on end.
To become invisible to enemy sonar, the submarine is wrapped in a magical suit called anechoic tiles. Thousands of specialized rubber tiles are glued across the entire hull. These aren't just rubber, they contain tiny air pockets that absorb enemy sonar waves instead of reflecting them. On a radar screen, this giant ship appears no larger than a small fish. This stealth coating is expensive and difficult to apply, but it's what makes the submarine the ultimate ghost of the ocean.
Now that it's invisible, it's time for the attack. Located on the upper hull are the vertical launch tubes, the submarine's teeth. These tubes hide intercontinental ballistic missiles and torpedoes. A single missile can travel thousands of miles and take out an entire city in seconds. The most terrifying part? The submarine can fire these weapons while submerged without making a sound. It is the most powerful and hidden weapon system on the planet. Over 100 people live together in this confined space for months. Space is a luxury. In a practice called hot berthing, 3 sailors often share one bunk in rotating shifts. However, the food is top tier. The kitchen features expert chefs preparing fresh meals to keep morale high. There's even a small gym and a cinema area. Being inside a steel tube, completely cut off from the outside world, requires incredible mental strength. Inside the submarine's walls are over 100 kilometers of wiring. These aren't just cables. They are high-speed fiber optics that carry data from sensors to the brain of the ship. Every connection is waterproof and shockproof to prevent short circuits during combat. Threading these wires through the tight spaces of the hull is one of the greatest challenges for engineers. One faulty wire could leave the entire ship blind and powerless. There are no windows in a submarine, so how do they see? Welcome to the brain of the ship, the control room. Instead of periscopes, they use high-definition cameras and advanced sonar sensors. Operators listen to sound waves to detect mountains or enemy ships miles away. Every screen here processes thousands of data points every second. This is where the $2 billion machine is commanded. One small mistake here could lead to a catastrophic collision. To ensure it can survive the chaos of war, the submarine must undergo a shock test. Massive underwater explosives are detonated near the hull to see if the structure and systems can handle the impact. After that, it dives to its maximum depth, the crush depth, where the pressure is at its peak. Engineers inside monitor every joint for leaks. Passing these tests proves that the submarine is an invincible warrior ready for battle.
Once all tests are passed, the submarine is officially commissioned into the Navy. It is now a silent guardian of the seas and a hidden nightmare for the enemy. From a simple plate of steel to a $2 billion nuclear marvel, this journey is a testament to human engineering. If you enjoyed this journey, hit like and subscribe to The Makeology. What mega machine should we build next? Let us know in the comments. Thank you for watching.